still remind him that the last time he sent the money, it was not enough to buy all the provisions.
Oh, sorry, I forgot to tell him.
Are you guys talking about money transfer to buy provisions?
Yes.
But don't you know about Baluwo?
Baluwo? What is Baluwo?
Baluwo is a service that your son can use to send provisions directly to you guys from the shop. And you don't have to worry about the exchange rate.
Tell me how Baluwo works.
It's very simple.
Just log on to baluwo.com and shop, or download the app on your phone. You can shop on the website or using the app to buy online basic products for your family and friends. With Baluwo, you decide what your money is spent on. Your money, your choice. Buy online products for your family and friends in the Gambia, Senegal, Nigeria or Mali. Baluwo, better than sending money.
Hi, my name is Buba Gajigo and you're watching Kerr Fatou. This is your educational program, and now we're gonna bring you lessons from senior school. If you have your kid attending senior school, get them prepared, and I hope you enjoy these lessons.
Are you thinking of owning your dream homes? EJ Investment is here for you. Secure our quality bungalows with 2, 3 or 4 bedrooms, or our story building 3 or 4 to 5 bedrooms at very affordable prices with flexible payment plans at our Sanyang Seaview Estate, where you can enjoy the cool breeze with modern infrastructure such as tar roads, covered drainage system, modern electrification with street lights, gated entrance with security posts, and social amenities such as gas station, shopping mall, medical clinic, park, schools, children daycare, and a lot more. Our dedicated team of professionals will keep the estate clean at all times, provide security and patrol team within the estate premises, install latest technologies such as CCTV, Wi-Fi, home network installation, solar panel, and power backup system. Also, check out for our additional home facilities and interior design service such as premium tiling, wall plaster, home landscape, fingerprint home lock, and a lot more. Visit our office at Senegambia Kololi Highway and get a free site visit tour, or contact us on 4464-838. WhatsApp us on 3259220. Or you can visit our Facebook page or Instagram on EJ Investments. EJ Investments, we are first in properties.
Calling ambulolo cool with whatever we do. Jioni safu no la with whatever we do. Hale yidemu new school. Nyepamne ne kudlukula. Nyepangi ragala gena. Nyepamne ne kudlukula. Ibuloke nungoto ni beti sola. Ibuloke dato ni betoto.
Mingi! Mingi Congo.
Lamin!
Na?
Lamin te jibe norin te nyame lamin.
Kabana wulo kono.
Wulo kono nyinta mo lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Lundambana. Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramudu man kontan.
Ngoto minaka ngala min je fom filitala. Lamin jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko mo la ko momo.
Ngoto.
Nam.
Iterinte yalo ne lamin hakilo diata bake karambu ngoto. anu santeng ministry ko di ngole si suo ko ama ke ko be holiday la
si bitun
bagona de
ala ni ku ke de namo balo
ala ni na ko na cartable be damna ala ni je
ngoto
nam
ngoto mon kontaan feren
jamna ni mu ne keda
ite ka lamin ki wulo ko no nyintai mon ko do fete malo lamin nyanta sila la be la moy kala karango
jamna ni karamol be soron ne ko fasita wulo ko nako
karambugol ma soron ni ko karambugol soron da amaka kom holiday lem ngoto dini ngo nyanta sila la ala karango la moy yamen kamen fue man kontaan andamande
alla nyin kombo courant adan dal kombo len do la jan karamol soron da doron kamen courant ma dal lo kombo e don dol fana na karamol soron je karamol soron lamin ada lo nyino la aman tara fe na sokon ala mu nekela
am lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko nyina di mod lamin ya mu na fonye
bir kabin mina kan tambita nteri maning Fatou tambite la sugal ala dinngol bebe siri be la moy ka
Fatou danso am fana tambita jele ni subala la ngaje dinngol be je talanta nen kili warol e be siri jele
sa lamin fanante ku kili wo ke no la ba lamin bita ka wulo ko no nyin taymo alamin
aman dara fenela
ite dine ko ni man si yakari lesinol la moy radio to e balon na
mu ne ka ke afonye ba nyara ni alon
telentel jikot
afonye ba mu ne be ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya ay tarije
bar ñarande kombo courant ho findira kombo ide na raje den sonka bay ko lamin manya tala wulo ko adu karam mo be so dafa nyambe be kala
ko to wole nati ba ngalle ni lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu ko no bari ni ko e sisu ko no be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulen ko to batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandi
ila subjector baby jele baby jele
wala nanga chocho moy fa dan so wolya ngombe tambi kana ngadi ningol de be ikadum bungo de ko kada mara mo
asototal de
la min mala be kara wala de
bari
laftalal ideal on ko inde every year second wala fourth
muna ni ko ma ko nde ko folle sinila ba nde le sinilo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat nyim fadam bulata ko ko me yen nati jambi la min nyanta karana ndel beji ko be nyine ka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wada ka munda kara mo man soro la min nyanta kara si so na radio
la sila le ayala le sino
ndal ko korna ko smolon
kilar ya
mo be ngala ko momo say mi do ni fano kera
benki bruce
ndal ko la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe guljan dala nyara nyar fo ko fendi mo la la min tayra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
imagine nani nyambol si zol le keje kisigi man si zol no le kafun ka nyoma bari nyambu kino ni manya na kafindi ni nambe ko zol la jam
ngalle limbeta de be nyambo do dilanna
nyara ni ko rin fennat nyara nata
ko bari famo ke da
ngata bungono tambi bungono nyara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awa betar la
bungono bismillah bisu diara
ye fungo tanka sina dolu tanka koro ta koro
Hi everyone, I am Mr. Babukar Au, your chemistry tutor, and today we will start from the properties of salts. But before that, we will go back to our assessment and then we will try and answer the questions together. And then the previous questions were one, that is number 1A, what is basicity of an acid? Hello everyone, I am Mr. Babukar Au, your usual chemistry tutor, and today our topic of discussion will be based on intermolecular bonding. Our previous lesson we started chemical bonding, and then we are able to divide chemical bonding into two. That is, we said it is divided into interatomic bonding and also intermolecular bonding. We are able to discuss about the interatomic bonding. And now today, we will base our discussion on intermolecular bonding. Now we said intermolecular bonding, this is a weak force of attraction between molecules. A weak force of attraction between what? Molecules. Now if you look at the model on the board or on the screen, we have HCl, one molecule of HCl bonding with another molecule of HCl. Now you can see that in the first molecule of HCl, there's a bond between the hydrogen and the chlorine. So that bond is intra-bond. That bond is containing inside the molecule of HCl. And that type of bond is called covalent bond. You can also see a bond that is represented using a dotted line between one molecule of HCl and another molecule of what? HCl. And this bond is between the chlorine atom from the first molecule and then the what? Hydrogen atom in the second what? Molecule. That means this bond is existing between what? Molecules. That's why we said that bond there is an example of intermolecular bond. That is intermolecular what? Attraction. But it is what? Weak. So the first bond, where we have hydrogen and chlorine in the first molecule, that bond is inside the molecule. That's why we said that bond is what? Is strong, because it's an example of covalent bond. So covalent bonds are stronger than what? Intermolecular bonds. So if you have covalent bonds that hold molecules together, those molecules, when they want to bond to form maybe a series of molecules together, in that case we have what? Intermolecular bond or intermolecular attraction, which is going to be what? Weak. It's not going to be strong as the covalent bonds. And then we have two main examples of intermolecular bonds. And then the first one is called hydrogen bonding. Hydrogen bonding. And then the second one is van der Waals forces of attraction. And then we will go into details to explain what we meant by this hydrogen bonding and also van der Waals forces of attraction. Now before that, let's just have a recap questions based on the what? Intermolecular bond and also the bondings we were discussing in our previous lessons. Now number one, a chemical bond is. We have options. A, an electrostatic force of repulsion. That is A. B, an electrostatic force of attraction. C, a physical connection between objects that are touching. And then finally D, none of the above. So we can crack our brains for something like 5 seconds. Now the correct option in this question is letter B, which is a chemical bond is an electrostatic force of attraction. We move to number 2, and number 2 reads, which of the following correctly ranks electrostatic forces from weakest to strongest? That is, we have letter A, covalent bond, ionic bond, intermolecular forces. B, ionic bond, covalent bond, intermolecular forces. C, intermolecular forces, covalent bond, ionic bonds. And D, intermolecular forces, ionic bond, and covalent bonds. So the correct option in this question is letter C, which means intermolecular forces are weaker than covalent bonds, and covalent bonds also are weaker than ionic bonds, which also means ionic bonds are stronger than covalent bonds, and covalent bonds also are stronger than intermolecular forces. Now, number 3, which of the following is pointing to an intermolecular bond? Now we have A, which is pointing an intra bond, that is between the hydrogen and oxygen in the same molecule. We also have B, which is pointing between oxygen and hydrogen from different molecules, that is intermolecular. We also have C, which is pointing between hydrogen and oxygen, which is also intra. And we know intra also is types of what? Intra is a type of interatomic bond. We also have D, which is pointing between oxygen and hydrogen. And then this oxygen and hydrogen are also found in the same molecule, which means it's a type of what? Intra bond. So the correct option here will be letter B, because B is pointing between oxygen and hydrogen from different molecules. We have number 4, and it reads, the arrow below is pointing to an A, intramolecular bond, B, ionic bond, C, intermolecular bond, D, both A and B, and E, both B and C. And then if you look at the model, the arrow is pointing a bond that is between oxygen atom and hydrogen atom, which is in the same molecule, which means the correct option will be letter A, which is intramolecular bond. Now we move to the types of intermolecular bonding. And then initially we said the first type is called hydrogen bonding. Now hydrogen bonding occurs between a very electronegative atom and a hydrogen atom, covalently bonded to an other very electronegative atom. For example, if you have HCl, that is the initial molecules we have, with an other molecule of what? HCl. So the bond between this chlorine and hydrogen is termed as intermolecular, because the bond is between what? Molecules of HCl. So the bond between hydrogen and chlorine is termed as interatomic, and this one will be intermolecular. But here we want to discuss about the nature of hydrogen bonding, and then we know that hydrogen bonding does not occur in all kinds of molecules. Now, the first thing is hydrogen is the only atom that can take part in hydrogen bonding because of its small size. Now this statement now is for what? The cation. Now any bond that is termed as hydrogen bond, there must be what? Hydrogen atom. And the reason here is because the small nature of hydrogen atom. And again, the electronegative atoms that form hydrogen bonds are FON, that is formed. 1, we have fluorine, oxygen, and then we have what? Nitrogen. So that is only these 3 atoms can form hydrogen bond with what? Hydrogen atom itself. Hydrogen must be present, and then when hydrogen is bonding with F, it can form something like HF. When hydrogen is bonding with oxygen, it can form H2O. When hydrogen is bonding with nitrogen, it can form ammonia. So these are the three molecules in which we have hydrogen bond. Now we use FON, that is FON, that is fluorine, oxygen, and nitrogen, because one, they are very electronegative. That is fluorine, oxygen, and nitrogen. These atoms are very, very what? Electronegative. The second reason is having a very small what? Nuclei. If you draw the bonding of fluorine, oxygen, and nitrogen, you'll come to realize that their nuclei is what? Small. 3. Having a relatively high charge density. High charge density. And high charge density is simply the charge of that element, or the ratio of the charge of that element to its what? Volume. So fluorine is -1, oxygen is -2, and then nitrogen is -3. So these three types of atoms have high charge density. Now these are the three reasons why these three atoms can react with hydrogen to form a hydrogen bond. Now we still on the note, hydrogen bonds with fluorine are what? The strongest. This is only applicable when you consider one of the factors, that is the electronegativity of what? Fluorine. Because fluorine is more electronegative than what? Oxygen. Oxygen also is more electronegative than what? Than nitrogen. So if you use the first factor, when fluorine reacts with hydrogen, that molecule will be stronger than when oxygen reacts with hydrogen, and also when nitrogen reacts with what? With hydrogen. But then we will try to explain which of these molecules, that is, which of these atoms, when react with hydrogen, is stronger. D. A hydrogen bond can be formed between two molecules when? Roman figure 1. One molecule has a hydrogen atom bonded covalently to a high electronegative atom. That is the first place. If you have your HF, we know that this is one molecule of hydrogen fluoride. So the bond between this hydrogen and this fluorine is called intermolecular, and it's a type of what? Covalent bond. Covalent bond. So when this bonds with what? Another molecule of hydrogen fluoride, now this type of bond will be what? Hydrogen bond, because the bond is inter, and again also is between hydrogen and fluorine, and fluorine is small. Fluorine has what? High charge density, and also the nucleus of fluorine also is what? Is small. And again 2, the other molecule has an atom which is also highly electronegative, small in size, and carries a lone pair of what? Of electrons. Now if you draw the bond of this HF, you have something like this. You have here 2 electrons. You have here 1, 2, 3, 4, 5, 6. You see now, they are what? Lone pair electrons. So these lone pair electrons now can easily what? Cause some attraction towards the what? Another electronegative atom. If this is fluorine now, when it sees hydrogen now, like this, in this case, we have hydrogen now. So there will be what? This is the hydrogen atom now. There will be what? Attraction between this fluorine and what? This hydrogen. Therefore, they will be able to form what? Hydrogen bond. So this lone pair electron can easily cause what? Attraction. Now we have a model on the board, and the first model there, we have 4 molecules or 5 molecules of water, and then the model is trying to show where the hydrogen bonds are located. Now you see the central molecule, you have oxygen, which is red, and then attached we have 2 atoms of hydrogen atoms which are attached. Now you see oxygen is having 2 lone pairs of what? Electrons. So each lone pair of electron is trying to what? Cause attraction to the hydrogen atom on the other what? Water molecule. So therefore at the end they will be able to form what? Hydrogen bonds. Now in the second molecule, you see the oxygen now is partially negative, while the hydrogen atoms or the hydrogen there is what? Partially positive. That is the 2 hydrogen atoms. So in the other molecule also you have oxygen still partially negative, hydrogen atom partially positive, the other hydrogen atom also is partially positive. Now there will be attraction between the partially negative oxygen from one molecule to the partially positive hydrogen in the other what? Molecule. So that there will be what? Force which may lead to what? Attraction. And then this attraction now, because it's between oxygen and hydrogen now, it becomes what? Hydrogen bond. Hydrogen bond. Now we have factors affecting the strength of a hydrogen bond. What can determine the strength of hydrogen bond? How will we know this type of hydrogen bond is stronger than the what? The other type of hydrogen bond. Hydrogen bond. And then the first factor here is electronegativity. Electronegativity. Now, initially we said electronegativity is the ability of an atom to attract an electron towards itself. Now, the more electronegative the atoms, the stronger the hydrogen bonds form. That is, if we have F, we have O, we also have N. We know F, that is fluorine, is more electronegative than oxygen. Oxygen also is more electronegative than what? Nitrogen. So we can say, regarding the first factor now, we can say HF is stronger than what? H2O. H2O also is stronger than what? NH3. But this is just based on the what? First factor. Now the second factor is number of hydrogen atoms formed. That is, the greater the number of intermolecular hydrogen bonds, the stronger the hydrogen bonds form. Now we consider F and what? O. That is fluorine and oxygen. Here we will have HF and here we will have H2O. So the bond in here, if you draw the structure, we will have something like this. See, this fluorine now, this hydrogen. We only have one atom of hydrogen attached to the what? Fluorine. And in this case now, we can have oxygen, we can have here hydrogen, we can also have here what? Hydrogen. Now you see we have 2 atoms of what? Hydrogen attached to the what? Oxygen. So therefore now, we can say water is stronger than what? HF, because water forms more what? Hydrogen bonds. The third factor is electronic structure of the other what? Other atoms. That is the other atoms that is trying to bond with what? With hydrogen. That is trying to what? Attract hydrogen. Now atoms with lone pairs of electrons that can point towards the hydrogen atom of a nearby molecule form stronger hydrogen bonds. That is, if we don't want now, let's compare oxygen and what? And nitrogen. Now here with hydrogen atoms we'll have H2O. With this we will have what? NH3. So if you draw this, we'll have something like this. You have your lone pair of electrons, lone pair of electrons. In this case, we will have 1, 2, You have here a single lone pair of electrons. So these two atoms are what? Hydrogen atoms, and these three are what? Hydrogen atoms. This is the nitrogen and this is the oxygen. But there are more lone pair electrons that can what? Point towards, or that can cause attraction towards what? A nearby what? Molecules. And here we have what? A lone pair of electrons, that is a single pair of electrons that can what? That can cause attraction towards what? A nearby molecule. Now therefore we can say this water molecule now will have a stronger hydrogen bond than what? Ammonia, because there are what? More lone pair of electrons in the water molecule than in the what? Ammonia molecule. The fourth factor is bond length. Bond length. Now, when the size of the hydrogen bonding forming atom Y is large, then we can say HY bond length will also be what? Large, and weak hydrogen bond will what? Will be formed. For example, if we have, if you want to compare H is bonding with X, H is bonding with what? With Y. You see now? And then we assume X is having 2 cells. And then Y is having what? 1, 2, 3 what? Cells. Now, if Y is bonding with what? With hydrogen, there will be what? Great distance. Compared to what? When X is reacting with what? With hydrogen. Because X is just having 2 cells and Y is having what? 3 cells. So there will be what? A greater distance in HY than in what? HX. So therefore, when these bonds are all, or when they are both what? Hydrogen bonds, we can say that HX will be what? Stronger. And now HY will be what? Weaker. Because the larger the distance between the hydrogen and the what? Other atom, the weaker the hydrogen bond form. And you can determine this using the size of the other atoms. Now we have some try questions. And then number 5 reads, which of the following molecules has hydrogen bonding as one of its intermolecular forces? Which of the following molecules has hydrogen bonding as one of its intermolecular forces? Letter A, HF, that is hydrogen fluoride. Letter B, HCl, that is hydrogen chloride. And letter C, HBr, which is hydrogen bromide. D is HI, which is hydrogen iodide. And E, all of the above. So in this case, fluorine is smaller than chlorine, smaller than bromine, smaller than what? Iodine. Because of the electronegativity nature of fluorine, and also its high charge density, and also its small nature, will make HF to be what? Hydrogen bond, and then B, C, D, and E will not be what? Hydrogen bonds. Which means the correct option in this question is letter A, which reads HF. Number 6, which of the following molecules has hydrogen bonding as one of its IMFs? And then it's the I stands for inter, the M molecular, and the F forces. That is intermolecular forces. Intermolecular forces. We have CH3F, that is methyl fluoride. We also have CH3Cl, which is methyl chloride. We also have C, which is HBr, which is hydrogen bromide. We also have NO2, which is nitrogen 4 oxide. And E says none of the above. Now the correct option in this question is letter A, because it is where you are having fluorine bonding with what? With hydrogen atoms. Now, whenever these 3 elements, that is F, O, N, form, whenever they are reacting with what? With hydrogen. We assume hydrogen bond is taking place. So no other atom apart from these three can form